Lever. A lever is a rigid body that rotates around a fixed pivot point called the fulcrum. It works by applying the principle of torque, which is the rotational equivalent of force. Torque is calculated as Q equals F times R, where F is the applied force and R is the perpendicular distance from the fulcrum. A lever creates mechanical advantage by increasing the distance through which the effort force acts. The ideal mechanical advantage of a lever is MA equals effort arm divided by load arm. When the effort arm is longer than the load arm, a smaller force can lift a larger load. This principle allows humans to multiply force while conserving energy. Levers are classified into first class, second class, and third class types, depending on the positions of the fulcrum, effort, and load. From crowbars to human limbs, lever systems are fundamental to both machines and biology. Wheel and axle. A wheel and axle consists of two connected cylinders of different radii that rotate together as a single unit. Because both rotate through the same angle, the larger wheel produces a greater linear distance than the smaller axle. The mechanical advantage is given by MA equals radius of wheel divided by radius of axle. This means a force applied to the larger wheel creates a greater torque on the axle. The relationship follows the rotational form of Newtonian mechanics. Tau u equals w F times r. By increasing the radius at which force is applied, the wheel amplifies torque and reduces the effort required to move loads. Wheel and axle systems dramatically reduce friction compared to dragging objects across surfaces, making them one of the most important inventions in transportation and engineering. Pulley. A pulley is a rotating wheel designed to guide a rope, cable, or chain. Its main function is to change the direction of force or increase mechanical advantage. In an ideal pulley system, the mechanical advantage equals the number of supporting rope segments. M equals number of supporting ropes. A single fixed pulley has a mechanical advantage of 1, meaning it changes only the direction of force. However, compound pulley systems distribute the load among multiple rope segments, reducing the effort needed to lift heavy objects. The operation of pulleys is based on tension forces, where the tension remains nearly constant throughout an ideal rope. This allows heavy loads to be lifted efficiently in cranes, elevators, and construction systems. Inclined plane. An inclined plane is a flat surface positioned at an angle to the horizontal. Instead of lifting an object vertically against gravity, the force is applied over a longer distance along the slope. According to the principle of work equals force times distance. The same amount of work is required to raise an object to a certain height, but the inclined plane reduces the force needed by increasing the distance over which that force acts. Its ideal mechanical advantage is MA equals length of slope over height of slope. As the slope becomes longer relative to its height, the required force decreases. Inclined planes are widely used in ramps, roads, and loading systems because they allow heavy objects to be moved upward with greater efficiency. Wedge. A wedge is essentially a moving inclined plane designed to separate materials. When a force is applied to the broad end, the wedge redirects that force outward through its sloping surfaces. The mechanical advantage is approximately MA equals length of wedge divided by width of wedge. A longer and sharper wedge produces a greater force amplification. The wedge works by concentrating force into a very small contact area, which greatly increases pressure. Pressure equals force divided by area. Because the contact area is small, even moderate forces can create extremely high pressures, capable of cutting, splitting, or piercing materials. Knives, axes, chisels, and nails all operate using this principle. Screw. A screw is an inclined plane wrapped helically around a cylindrical shaft. As the screw rotates, its threads convert rotational motion into linear motion. The key property of a screw is its pitch, which is the distance advanced during one complete rotation. The ideal mechanical advantage is MEA equals circumference over pitch, or ME equals 2 PIR over pitch, where R is the radius of the screw. A smaller pitch increases mechanical advantage because more rotations are required to move the load the same distance. This allows screws to generate large forces from relatively small turning efforts. The screw is one of the most efficient force-multiplying simple machines and is widely used in fastening systems, presses, jacks, and precision engineering devices.